Makadev Training. Hello, this is Dr. Naveen Sundar from Karunya University, and today we are going to see the k-means clustering. So, as you know, the k-means clustering is it's an unsupervised learning. Okay, so you know the difference between the supervised and unsupervised learning in machine learning. Here we are not having any dependent attributes. So let us check the data set so that easily you will understand. And I will just show you the data set what I have used for this k-means clustering so that you will get the clear idea about it. Yeah, it is already there. So I can use the mall customer.csv. Yeah, let it make the screen little bigger so that easily you can view the. So you can see here all these are all independent attributes. So we are not having any dependent attributes in this data set. So it is like a mall customers. So here we have the gender of who is the person going for the mall, and then what is his age and what is his income and how much he is spending for that particular day. Okay, so that is how a person, it's a customer ID. Okay, so it may be for year or it may be day or it may be, okay, so whatever it may be. So likewise, according to the income and how much he is spending, likewise, we are having, no, we are not having any um, dependent attributes in this thing. Okay, so how we are going to use these data set and going to find the k-means. In the previous thing and all, we have the dependent, like in the initial time, the person whether going to purchase the loan or not. Okay, so depend upon the salary. We have seen so many supervised learning, but this is unsupervised learning in which you can see there is no dependent attributes in this. Okay, so whether he is going to be the member of the mall or non-member, like that, we are not going to give any answer to it. Okay, so that is with this data set, how we are going to form the clusters. So that is our target in this k-means clustering. And let us see the code directly. And also, many are predefined functions. And how to do it, I will just share it in words so that easily will understand the k-means clustering. Okay, so directly now we will go to the code and I will tell you, okay, so as you know, import NumPy as NP, as you know, numerical Python, and then this is for matplotlib for visualizing the graph and how we are going to plot it. And then import pandas as PDA, as you know, everything is in the form of the data frame. And then we have to import, this is the thing we have to be very clear with. sklan dot cluster. Okay, so here as we are going to create the cluster, we are going to have like sklan dot cluster from that package. We are going to import k-means. Okay, so that is the algorithm or model we are going to create. And this is like from sklan dot metrics in which we are going to import. These are the performance metric we are going to use. That is the Silhouette score and the Davis Baldwin score. So this Silhouette score, which will be range like it will be range between -1 to 1. That means what we should have a maximum value that is close to the one. Then we can say that the performance is good. And when we see the Davis Baldwin score, the range should be less. Then the performance metric will be good. So this is how you should know about these performance metrics which we are going to use for the k-means. Okay, so as you know, first we are going to input the data sets as we saw the data set. Okay, that is small data set in which we are having annual income, spending score, gender, okay, and also customer ID. Likewise, so many things we have seen in this particular mall customer CSV file, in which I'm going to take only annual income and only the spending score. That is enough, right? Then with that, we are going to form the cluster. Okay, so depend upon the annual income and spending score, we are going to form the clusters. That is the properties, okay, which is features which is more similar to one another. We are going to create it into different clusters. So it's our target is how many clusters are going to form. Likewise, we are going to find out by means of an Euclidean distance, in which we are going to create a centroid for it. Okay, so for that only we are going to use the elbow method. So elbow method is like the sum of the square of distance. Okay, that is WCSS. We are going to find out. That means what? It is like the sum of the square of distance between the centroid and the data points. Okay, so let us see the code in which I will just tell you about what is this is all about. I will just once again I will just look at we will look at the data set in which if I for example, okay, so if I am going to take consider the randomly selecting the centroid as the first column and the fourth column. See, for example. Okay, so then this first column and fourth column, if I'm taking it as a centroid, so this will be considered as x comma y, and for the fourth, this one will be considered as x and y. This 16 and 77 will be considered as s and y. As you know how to find the Euclidean distance, that we will consider each and every this row we will consider as an object. Okay, and we have to see which value which is closer to the object, and then we will say that is belong to that particular centroid. So that is how we are going to find out the minimal value of D1 and D2 we are going to find out. For example, D1 means the first object we are taking, and then what we are going to do is in which the first object will be considered as A and B, and the centroid also same A and B. So x minus A plus y minus B the whole square means like 15 minus 15 and 39 minus 13 it will come, and both will become like 0, right? Similarly, for the first object, we have to consider the second centroid as well. So, in which is the minimal value we have to take. So, 0 is the minimal value. So, we can say that this one belong to the centroid 1. Got it? And then consider the second object. That also will be close to the centroid 1. And then that 3, it will be close to the centroid 2. And fourth, when you are making it out, considering this 1 and 4, this 4 will become like a 0 because the centroid value and the object value which is same 16 and 77 only we are going to take. So then from 4 onwards we will make it as like all these things will be close to it because we have arranged in an ascending order of annual income. When you are calculating, if any variation comes, we have to put it into the centroid 1 or centroid 2. Likewise, we have formed a group. Okay, and then we will take that new value as a new centroid value, and then we have to continue the iteration process until if all these things become the same. See, for example, one particular group is 1, 2, 3 will become the one group, and from 4 to 10 it will become the another group because that belongs to the centroid 2 and this belongs to the centroid 1. So when we are going for further iterations, when the same result comes, then we are going to stop the iteration. This is how we are going to do the initial step. Okay, so I hope you understood about how to do this WCSS. Okay, so in which initial point is doing this finding the centroid. Okay, random centroid and finding out the centroid at the doing the maximum iteration and finding the best centroid points. Okay, out of the different objects what we are having. And then we have to using this elbow method in which the sum of the square of distance between the centroid, as I told you, the final centroid what we discuss after finite iterations, that centroid and the distance, okay, sum of the square of distance between this centroid and each data points. As I told you, for the first object, second object, third object, like that, we have to take for each and everything, and then we have to find the optimal number of clusters. Okay, so for example, if I am taking for I in range of 1 to 11 means, okay, so that is 1 to 10. Okay, I have to make that much of iterations. Okay, so that only we are doing actually here in iterations, and then we are giving like k means. Okay, so here we are going to called the k means, in which I'm giving n clusters equal to I. That means first cluster 1, and then it will be 2, and it will be 3, and it will be 4. Likewise, up to 10, it will be incremented one after another. Okay, and then we are going to give the init equal to k means plus plus. Okay, so that is the model name we are going to give, and random state equal to 42. Why we are giving like this means it will be fixed, or otherwise every time the centroid value will change. So that's why we are giving the random state equal to 42, means it will take a particular value as a centroid, and it for each and every object we are going to check, it will not going to change. Once that it get over, and then the centroid value will be changed, and the next object will be mapped, and then it is going to find out. Got it? So that's why we are giving this random state equal to 42. And why this we are giving a k means dot fit of x. Okay, what is this fit? This function really it performs two operations. One is the fit of x, and another one is predict. Okay, fit predict of x. What is the meaning of this fit of x? That means it trains the k-means model on the data set x by calculating the centroid and assigning each data point to a cluster. So that's why we are using this fit. Okay, first initially we have to go for the training. Okay, training process is the k-means model, right? What about this predict? That after training, it assigns each data point in X to the nearest cluster and returns the cluster index for each point. Okay, so that's why we are using this fit and fit predict of X. Okay, so when we are using like this, then it need training, and then based upon it, it is going to assign each data point in particular X to the nearest cluster. Okay, to the nearest cluster, and return the cluster index for each point. Okay, so that is how we are using, why that's why we are using this function. And then we have to append it so that the next the range. Okay, so it will move up to 10. Okay, so for that we are incrementing it. Okay, so as you know, this is how we are going to plot for WCSS, and which one in the elbow method we can see in the graph. You can see that here it is like a big uh, edge. Okay, so you can see a rapid change in this. So we can plot here, and we can find out the number of clusters is 5. Got my point? This is how we are just pointing for each and every object in WCS, and we are just making it out from a range 1 to 10, as we said. Okay, so we are plotting one after another for each iteration, and we can see that sudden reflection. Okay, so that we can consider it as like the number of clusters. Okay, so that we have to find out the number of clusters. If the point is reflecting here, means we will say the number of clusters will be 7. So that is how we are just finding out the number of clusters in here. Okay, so that is the thing we are actually doing in this elbow method. That's why we are giving the range as 1 to 10, and finding out using the elbow method number of clusters is how many things. Okay, so after knowing this, just we are going for training the k-mean model, as I discussed for fit. Okay, fit predict, as I told you, initial training will be done, and then according to it, it will be fixed to the object. Okay, and then we are going for the performance metric. Okay, so when we go for the performance metric, as I told you, we are going to calculate the Silhouette score, and okay, so we are going to have find out the Davis Baldwin score. Okay, so that only we are going to do it. Okay, that is the performance metric for the k-means, as we discussed. And the range of value for Silhouette is -1 to 1, and it should be close to 1, means the performance is good, and Davis it should be lesser value. Okay, so that we can say that the performance of the Davis Baldwin score will be good. Okay, so that is the code which is used to find out the performance metric for this thing. Okay, so y x is like and then y k means that between this only we are going to find it. One will be the object value, and another one will be like the mean value we are finding out the centroid. Okay, so with that we are going to find the performance metric for cell score and TB score value. Okay, so likewise I have found out, and then we have to show it in a table format also. As I shown you through the graphical format, in the same way, if you want to show it in a table format, sometimes creating the data frame for the result. So just we have to give the result df, that is the function name, in which I have to give PD, okay, pandas dot data frame of results. So when I'm just giving this function name to be called, and then it can be printed. Okay, print results df. Okay, so this is like I am printing the title. Okay, so when you just look at here, you can see that performance battery for different k values, and it is in the data format, and for the object name and for the centroid, and I am getting the performance metric, okay, in Silhouette score and David Bolte score. Okay, so this one, it should be close to the one and should be minimal, can show the performance is good compared with the different iterations. Okay, and visualizing the cluster, and you can see that I want to visualize all the clusters. Now I know the number of clusters is 5, and then I want to see the features which is close to each centroid. Okay, so according to that, it should be converted into the clusters, that is forming group together. When you see here, based upon the different centroid, you can see that these are all the data points which is having the same features, and these are the data points which have the same features. Okay, so likewise, you can see that 1, 2, 3, 4, 5 clusters we have formed, and this yellow is, we can call it as like a centroid, and we can see that in each iteration, okay, which are all the things that is close to the centroid, that alone form a different color, and then formed as like different 5 clusters, which is close to the centroid. That is how it is grouped together. Okay, according to that similarity measures, right? So as a result, you can see that using this k-means without, okay, any dependent, okay, attributes depend upon the data set itself. Okay, we have find out using the centroid method. Okay, and then we have find out the data points which is close to the centroid. Okay, and initially we found the number of clusters what is required, and then we have finished the thing. Okay, so this is how I have grouped together, and I have got the result, and I found the performance metric as well. I hope you understood this k-means clustering. Okay, it is an unsupervised learning. I hope you all understood. All the best. Thank you.